In this video, I introduce the first-order model-agnostic method learning. Method training dataset is split into a training dataset A and a test dataset B, as shown here. When a language model alpha theta adapts to a new task Ti through gradient updates, the new model parameters theta I prime is updated by using this formulation, where alpha is the step size and L is the loss of the task Ti. The model parameters theta are trained by optimizing for the performance of alpha theta I prime with respect to theta across the task sampled from the tester B, as shown here. Where beta is a matter step size, matter optimization is performed over model parameters theta, whereas the objective is computed by using the updated model parameters theta prime. MAML optimization involves a gradient through a gradient, one gradient in the inner loop, one gradient in the outer loop, which requires an additional backward pass through F to compute the hashing of L. MAML finds the optimal model parameters theta such that for a randomly sampled task tau with the corresponding loss L tau, a language model will have a low loss after K updates, as shown here. Where U is the operator that updates theta for K times using data sampled from tau, and E tau is the expectation over task tau. In few-shot learning, U performs a gradient descent on batches of data sampled from tau. MAML solves the minimum problem above using assumption. For a given task tau, the inner loop optimization uses the training samples in A, whereas the loss is computed using the test samples in B, which is generalized by this cross-validation. Under this assumption, the minimum problem rewritten is here. MAML solves this minimum problem through stochastic gradient descent. MAML computes the gradient of a loss function L with respect to theta as shown here, where theta tilde is U and U prime is a Jacobi matrix of the update operation U. U corresponds to adding a sequence of gradients to the model parameters as shown here. The first order MAML treats the gradients G from 1 to K as constant and replaces Jacobian U prime by the identify operation. Namely, the first order MAML uses G as a gradient in the outer loop optimization to avoid the hashing computation. The first order MAML is implemented in a simple process. First sample task tau, and then apply the update operator using theta tilde, and then compute the gradient at theta tilde, gather a G, and finally plug G into the outer loop optimizer. For more details, please check with these references. Thank you. Bye.